Welcome to the third session of Computer Networks from Scratch. In this session, we shall be talking about IP address, version 4, default mask, public versus private IP address, and then we'll see some practical associated with it. Now this approach would be very vital for those who are appearing for GATE examination, for engineering students and anyone seeking knowledge. And remember, if you are not subscribed, please subscribe and press the bell icon button so that you get the updates immediately. Let's start. This is our first question of today. You have seen this symbol? Yeah, you are right. This is power switch symbol. But why is it so? We'll talk about it at the end of our session. One more question. We said that we'll be talking about IPv4. Is there any other IP addressing scheme? Yeah, you will say that there is something like IPv6. But do you know that it is from IPv1 to all the way IPv15? Yes. And we'll talk about IPv1 to v15. The importance of it is the conceptual understanding. It is the conceptual understanding of the networking which is made absolutely clear once we start our journey from v1 then all the way to 15, and trust me, it is very interesting. So let's take a real life example. Here is A, and let's say this is post office A, this is post office B, and here is the recipient B, right? So A writes a letter, puts it into envelope, addresses it and posts into post box. It reaches to post office. Post office is receiving so many other letters also. Collectively all of them, they are put into aircraft. Let's say it sends the message that we are sending from A to B 550 letters. They are reaching over here, sorted out, and then finally B would get that message. That letter will open and here is the matter. From the user perspective, if you see, both these users, they are interested in the content, that what exactly is written into that letter. So they are communicating. For them, this piece of information is important. These post office, they would say that okay, I have sent you 550 letters. Even this post office B would say, okay, yes, I am also sending say 739 letters. So it means whatever the communication which is going on between post offices, that is for their administrative part. They are not at all interested in that what was the content of that letter, whether it was a resignation letter, whether it was an invitation letter. No, they are not interested into this content. They are interested in how to deliver this information from one point to the second point. So there are two types of communication going on. Now look at this. It's almost the same. Over here, instead of user, we have got our devices. So we can very well say this is A, this is B. This node A is connected to, let's say, router A. This is router B. They are connected, and then these routers, they will be routing the piece of information from one router to another router. So what routers are doing, that is similar to what post offices, they were communicating with each other. So over here, this is called as the routing protocol. And what users are communicating, where the data is traveling, it is called as the routed protocol. It is called as the routed protocol. The examples are like, say, this is TCP/IP, IPX/SPX, AppleTalk. But this IPX/SPX, they are no more in use. Only TCP/IP is in use. And regarding this routing, there are so many routing protocols and in our future sessions we'll be talking in depth about all those. Now let's talk about IPv1 and IPv2 together. This came in 1974 and this came in 1977. Now both of them, they are nothing but just names of TCP protocol. Because it is at that time the data and the routing, they both were getting tried to be sent on TCP only. John Postel, who said कि no, this is wrong, it cannot be done, so we need to make some changes. And this was the proposal which led to, in 1978, the IPv3. So it was the IPv3 where TCP was used for handling data and IP which was used for routing. So this was one of the very important concept. So in IPv3 it was with variable length IP address. It was version 3.1 in which this variable length address was removed. Now you can say that it is version 3.1 which gave birth to IPv4, which is nothing but a polished version of IPv 3.1. Right, so this is the version IPv4 which we are using, and that is our main topic of today's discussion. IPv5 was just an experiment. It was Internet Stream Protocol. Now this Internet Stream Protocol, as such, it was like a failed experiment. So that's why it never came out of the labs. IPv7, it was proposed in RFC 6814. Now what is this RFC? RFC is a request for comment. It is request for comment. Right? What request for comment is? It's like all these new ideas, new inventions, they are put it in the form of documents, and you can really access these documents in ietf.org. Right? So we're there. If you go to ietf.org and you give 6814, they'll be giving you in-depth details about IPv7. Now this IPv7, it is also called as the next internet. Yeah, that's what it is called, the next internet. Now this next internet, why is it so that the next internet? Next internet is because they said that this TCP IP is very heavy. It is having so many parameters. Right? There are so many parameters, but are all these parameters in use? Actually no. They deprecated or they removed some of the parameters, and this entire concept is said in the form of IPv7. So that is deprecated options of TCP IP. Now this IPv8, this was proposed in RFC 1621. Now this is PIP. P, Internet Protocol. Now this protocol is said to have some very rich capabilities, very rich routing capabilities. to be precise, very rich routing capabilities. That is with much better option and much better speed capabilities. But again, this is just a proposal. Okay. IPv9, which is RFC 1347, and it is also called as the tuba. Now this tuba is TCP and UDP for big address. UDP for big address. That's why TUBA, tuba. TCP and UDP for big address is meant for long-term solution for internet expansion. So that's the meaning of IPv9. So IPv10 to v14, it is unassigned. So for all the future developments and for the future ideas, we have got IPv10 to v14. So that's something which is for you. And this is IPv15, which is simply reserved. At least at this point of time, it is reserved. In case of networking, what exactly is networking? Networking is where these devices should talk to each other so that they share information and they share resources, right? They share resources. Now it's so vital that whenever this communication is going on, it is the identity which is so important. We talked about this even in our second session, identity. So this is your name which is fixed, and we said that this is something which is very similar to MAC address, right? It is the MAC address, the 48-bit system. Regarding this second address, this address is your location. It's the location which is variable, which will keep on changing as you move from one city to another city or one place to another place. And this is equivalent to IP address. Now whether it is IPv4 or v6, because they are used in IPv4 and v6, they are used in our day-to-day life. So IP address v4, IP address v6. This is a 32-bit system and IPv6 is 128-bit system. So they are called as the software address or logical address, and they change with change in network, right? So they change with location. All right. Regarding bit, byte and octet. Bit is nothing but binary digit. So if I say that in binary I write 101, so this is how many bits? 1 bit, 2 bit, 3 bit. So this is a 3-bit number, right? 3 bits. Okay, such 8 bits, 1 2 3 4 5 6 7 8, such 8 bits, they will be called byte, right? They will be called byte. And octet, because there are 8 bits, octet is nothing but group of 8 bits, right? Or 1 byte. Structure of IPv4, we said that this is a 32-bit addressing scheme. These 32 bits, they are divided into 4 parts. Sorry. This is dot. Okay. All these are dots. So 8 bits here, 8 bits here, 8 bits here and 8 bits here. So we'll call this as first octet, and similarly this would be the second octet, third octet and fourth octet, and they are called as separators. They are called as separators, right? So these dots, they are the separators. It is the first octet which is of utmost importance. So let's focus at this point of time only on first octet. So here is the first octet. If I reserve this thing to 0 and then I give you the liberty that rest of the bits, they can be either 0 or 1, but all cannot be 0, all cannot be 1. Then what would be the lowest possible number in such case? Now if you see, we start putting 0, 0, 0, 0, 0, 0, 0. No, this cannot be 0 because all cannot be 0. So we have to put 1 here, right? So I just write 1 here. This would be the smallest possible number. So it would be 1, correct? Because this was 2 raised to 0. So this is the smallest possible number. Then for the highest we start putting all of them as 1, 1, 1, 1, 1, 1 and 1. Yes, 1, because 0 is already there and this is fixed. It cannot be changed. This is fixed. So what would be the value of this? Say this is 64, 32, 16, 8, 4, 2, 1. We add 64 plus 16 is 80, 32 plus 8 is 40, 4, 5, 6, 7. This is 7. So total becomes 127. Now this 127 number is a special number which has been reserved, right? It has been reserved. So we use 126. And this is nothing but class A. Class A, where the range is from 1 to 126. So remember this. Okay, moving on to the next example. This time we reserve 2 bits, 1 and 0. So what would be the lowest possible in this case? Keeping same rules, all cannot be 0, all cannot be 1. So we'll put 0, 0, 0, 0, 0, 0 and value of this is 128. So our lowest possible number would be 128. And putting the highest possible number for this, we'll put 1, 1, 1, 1, 1, 1, right? These are reserved, so we can't change it. So this would be 32, 16, 8, 4, 2, 1. 64 is 0, so we are not taking it. So 128 plus 32, that is 160. 16 plus 4 is 20. 8 plus 2 is 10, and this is 1. So 160 plus 20 plus 10 plus 1. That gives us the value, the highest value would be 191. And this is nothing but class B, right? Let's take one more example. So this time we reserve 110. This much is reserved. This is reserved. So with the same rules, all cannot be 0, all cannot be 1, right? So over here for the lowest number, we'll see 0, 0, 0, 0, 0. So this gives us the value. This is 128 and this is 64. So 128 plus 64, this gives us the value of 192. For the highest possible number, we'll keep this is 1, this is 1, this is 0, so they are fixed. We put 1 here, 1, 1, 1, 1. There is already a 0, right? So this 32 will not be taking, so we'll add 16, 8, 4, 2, 1. So this 128 plus 64 plus 16, that is round figure 80, 8 plus 2, it is 10, and 4 plus 1, that is 5. So this gives us the value 128 plus 80, 208, plus 10, 218, plus 5, 223. So this is the highest number, 223, when these 3 are reserved, 3 bits are reserved. So this is nothing but class C, right? Now let's say we reserve 1, 1, 1, 0. This is reserved. So what would be the lowest and what would be the highest number? Just pause the video and do write the figures. What would be the lowest and what would be the highest number? So we put all zeros over here. So this is 128 plus 64 plus 32. The total would be 224. 128 plus 32 is 160 plus 64, so that is 224. And the highest number, so this would be 8, 4, 2, 1. 12 plus 2, 14, plus 1, 15. So 224 plus 15, that will give you the value of 239. And this is what is called as the class D. So the whole idea is that the bits which are reserved for class A, class B, class C, class D. Here it was 0, here it was 1, 0, 1, 1, 0, 1, 1, 1, 0. I hope you are looking a pattern, correct? There is a pattern. So here is the quick summary of all the classes what we discussed. Now class A, B, C, they are used commercially. Class D, which is used classically for multicast, and class E, it is only for the experiments. Now in class A, class B and class C, those which are used for commercial purpose, now they are divided into 2 types of bits, network bits and the host bit. This concept is very vital. As we said that the whole IP address is divided into 4 octets. It is the first octet which is defining that in which class are you. So if there is one IP address at 200.4.13.9, but this first octet, it is 200, it is class C, right? Another IP address 172.15.16.17, which class? Watch just for the first octet, 172, falling in class B. Yes, 122, 191, class B. Okay. 127.1.1.1. This is reserved for what's called as the self-test. It is used for self-test or self-diagnostics. Okay, how about this? 100.200.200.201. No worries. This is first octet is what we'll watch, and this is class A, right? What about this address? 45.145.245.345. 45, okay, we'll say it is class A. is this 345 possible? So not possible, because in one octet, when all of them are 1, so the total would be, this is 128 plus 64, the 192, 192 plus 32, 224, 224 plus 16, 240, 240 plus 8, 248, 248 to 252, 252 plus 2, 254, and last one, that is total is 255. So highest possible number would be 255. Okay, so class A, as we said, that there are network and host bits. So in class A, there is first octet which is meant for network, and the rest of the 3 octets, they are for host. So here it is that network bits in class A, there are 8 bits, and host bits, they are 24. In this case it would be 16, 16, and in this case, that is class C, it would be 24 and 8. Class D, we talked about, it is working on multicast, and class E is for experiment. Okay, now we come to the concept of mask. Now see, in class A we said that it is network, host, 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 right? In class B it was network, network, host, host, and in class C it was network, 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 host. So how many network bits and how many host bits? Here it would be 8, 24, class B 16, 16, class C it would be 24 and 8. So what exactly is mask? Mask is when network bits, they will be made 1 and host bits, they are made 0. So over here, this entire thing, this entire octet, it is a network octet. So 1 1 1 1 1 1 1 1. So this would be 255 and 0 0 0, because all host bits are 0. Class B, it would be 255 255 0 0, right? And in class C, this would be 255 255 255 0. Now same things, they can be written like slash also. So in class A, it can be written as /8. Why? This is indicative of number of network bits in case of default mask. So yes, there are 8 bits associated, so we'll call it /8. Now you must have guessed, class B, it is how much? 16 bits which are used for network, so it is /16. Class C, it is /24, right? Because 24 bits, they are for network. Now when we talk about IPv4, this concept of public and private IP address is very important. Now public IP addresses are those which are mandatory when you want to go on internet, and they are not free. There is a subscription, there is money associated, and something which you are paying to your service provider, ISP. In fact, in RFC 1918, they gave the details of private IP address. So in private IP address, it was given in RFC 1918. Private IP address is for internal networks only. It is free, yes, and their range, they are fixed. For class A, it is 10.x.x.x. X means it can be from 0 to 255. So that was class A. For class B, 172.16.xx to 172.31xx. And for class C, it is 192.168xx. Because class A, so 8 bits, yes, this makes sense. Class B, why it is /12? because 8 bits here, and for this second octet 1 2 3 4 5 6 7 8, right, it is 16 to 31. So if I make the binary of 16, so this is 128 is 0 0, right, this would be 64, this would be 32, this will be made 1, rest of the bits they are 0. To 31, if I make 4 5 6 7 8, right, the binary of 31, that would be 1 1 1 1 1. So the point is, these are the 4 bits which are reserved. They are constant, they are same. So that's why 4 bits over here. So 8 plus 4, that is 12. That's the reason it is 12. These are the number of bits which are fixed. They will not change. So that is the meaning of /8 and /12. Now it is easy to guess in class C, right? Full octet, first 2 full octets, 192, 168, they are fixed. So that's why 8 plus 8, that is 16. So 8 plus 8, that is 16. Now there are some special IP addresses. The IP address 169.254, it is also called as the APIPA, Automatic Private IP Address Allocation. Now what it is, that let's say if there are more number of machines, then you require what's called as the DHCP, Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol. Now this DHCP, it's a server. Server is someone who gives services, right? That's a definition of server. So if there are more number of PCs, so this DHCP, they can give IP addresses to these machines automatically. Now interestingly, here is a DHCP server and it is connected. Let's say here is a switch and it is connected with several nodes, right? Several PCs. And in case if DHCP is not available for any reason, whether it is a cable break or the switch is not functioning, or if there is some problem in the DHCP server, these nodes, they will start picking up the addresses from this range. So let's say this might take 169.254. This is just an example, say 11.2. So then another will take address which is not 169.254.11.2 but something else. So that's how they will start taking those addresses by themselves, and that is something which is collectively called as the APIPA, Automatic Private IP Address Allocation, in absence of DHCP server. This is in absence of DHCP services, right? DHCP services. So here is the practical of APIPA, and it is being done on Cisco's Packet Tracer. And this is a free utility which you can download, and it's a very good system for practice. Now to save time, what I have done is, say here is our server. This is a DHCP server which I have already configured. So I have started the DHCP services, and the second is I have created a pool. Pool means the range of IP address, right? So it's a range of IP addresses. These are our DHCP clients. That means they will be getting the IP addresses from DHCP server, right? So first let's have a look at DHCP server. Here is our DHCP server. That's the IP address given to it, 192.168.10.100. In the services, here is DHCP. That service is on. So here is the server pool, right? And it is 192.168.10.0. So it will start giving IP addresses from 10.0 onwards. So .1, .2, .3. That's how it will keep on giving the IP addresses. Let's check. Here is our node IP configuration. So it has received 192.168.10.1. Now if I make it static, right, let's make all of them static and test again. Now let's check our nodes. We go to IP configuration. Now this is static. I'll make it DHCP client by configuring IP configuration from DHCP. It is requesting IP address. Here it is 192.168.10.2. Right? Let's check this. IP configuration, DHCP. Here it is 10.3. So it will pick up the IP address from that pool. 10.4. Right? So that's how they will pick the IP address. Now for some reason, if DHCP server is not available, right? So let's delete the cable. Now as we have removed the cable, now let's go and check IP configuration. We make it static and then we make it DHCP. Let's see. It is requesting IP address, but there is no DHCP. Here it is. APIPA is being used. DHCP failed. 169.254.146.64. Same thing would happen to everyone. So here it is. We make it static and we make it DHCP. It is requesting IP address from DHCP and APIPA is being used. See, it is different. 169.254 remains the constant. The rest of the two octets, they will vary. And the third one, same way. We static, we make it DHCP client, and because DHCP server is not available, here it is, APIPA is being used. So that's the whole idea behind this, that APIPA, it will come into picture. Remember the keyword when DHCP services, they are not available. So we now look at one more special IP address, and that is 127.x.x.x. This is also called as loopback. The purpose is self-diagnostics or self-check. This is to check our own TCP/IP stack and to check our own network interface card, whether it is working okay or not. Let's focus on PC number 2. So here it is, command prompt. So we ping 127.0.0.1. Now not only 127. Now if we ping 127.137.147.157, even that would be successful. The only IP address which won't be successful in this range would be ping 127.255.255.255. Technically this should not ping. Okay, let's check it out on real system. So we just give CMD and Here it is. So we ping 127.0.0.1. Yes, that's successful. We ping 127.255.255.254. Well, that's also fine. It's 255, it is a broadcast and it should not ping. Yeah, here it is. So this is the thing, right? Definitely that's a bug in packet tracer. So here we can see that this is ping 127.255.255.255 is not working, and that's fine. It should be like that. The next command to check is ipconfig. ipconfig and ipconfig/all. This will be giving us more detail, while this ipconfig will give us the basic details. So let's see that. ipconfig. So we can say it gives us IP address, subnet mask and default gateway, while when we give ipconfig/all, so it gives us, most importantly, IP address, subnet mask, default gateway, DNS servers, DHCP server, right, and the physical address. This physical address is nothing but it's the MAC address. You are right, it's a MAC address. We now look at ns lookup command. Now ns lookup is, it gives us the associated IP address with the specific domain. Say for example, when we type cisco.com, this cisco.com is associated with a specific IP address, and it is the DNS server, domain name services, DNS server, who is handling this functionality. So that's why this NS stands for named services. That's another name of DNS server, named services. So we'll give the command ns lookup space, let's say cisco.com. So we'll give ns lookup space cisco.com, and here it is. It shows that cisco.com has been resolved at 72.163.4.185. This is IPv6, which we shall be studying in our future sessions. So if I now ping cisco.com, see here, it matches. This is pinging cisco.com. It resolves at 72.163.4.185, 72.6.163.4.185. And there is one more command, that's say tracert. It traces the entire path. So if I give tracert cisco.com, so here it starts tracing. Now this thing will take some time, right, because it goes quite slow. So once this is finished, I'll return with the final result. So that's done. If you see, it traced all the way. So that's tracert, where it traces the entire path up to the destination. Alright, so this takes us to this question of today. This was a question that this is a symbol of power switch, right? Why so? Now see, there is a very important practical implementation associated with it. This is the answer. See how interesting it is. This is what? It's a binary. This is 0 and this is 1, right? And this is a combination of both of them. Now you know 0 is what? It is off and 1 is on. Alright, but here is the practical implementation of it. This switch is in on position or off position. Now I know you are smart enough to say that okay, here it is, right? That light is on. But watch for this. This is 1. This is 1, so it is on. So even if there is no light, still you can say that this is in on position. Okay. How about this? Now it is so easy to guess, right? This is 0, that is pressed down, so this is off, right? So in next session we shall be talking about a very interesting thing, and that is subnetting, right? We'll talk about subnetting. It is how these IP addresses, they can be divided into subnets, and we'll see some practical associated. Thank you so much. See you soon.